Good morning. Good morning to all
Very
of
morning,
you.
ma'am.
Yeah, very good morning. So today we'll discuss some of the problems related to centroid. Yesterday's class we have seen the centroid is the point where the entire area is assumed to be located. Okay. Suppose in case of rectangle, centroid always lies at a distance b by 2 and d by 2. Okay. Now we'll see this problem. This is in the form of a T. Okay. Determine the centroid of this T-shaped section. Okay. This T, okay, it consists of upper, this portion we call it as a flange, and this portion we call it as a web. Okay. That is the technical terms in case of structures. Okay. So upper portion, upper flange is of 150 by 10, upper rectangle, and the entire depth of the section is 150 millimeter, and this web thickness is 10. So that means this rectangle, top rectangle is of size 150 by 10, and the bottom rectangle is of size from 150. If I deduct this top 10, so this size is 140 by 10. Okay. First step. So we have to see, given composite section, how many simple geometrical shapes you can see. So where you know the centroid, we have the simple geometrical shapes like circle, rectangle, triangle, semicircle, quadrant. These are all the simple geometrical shapes. So here, how many shapes you can see? You can see two rectangles. In the given composite area, you can see only the rectangles, two rectangles. Now, next step. First, you have to see how many shapes. So we have one top rectangle. I had written it as 1, and the bottom rectangle is 2. Okay, and see whether is there any symmetry. So symmetry in the sense, if you pass exactly at the center. Okay, I am passing like this exactly at the center. See why I had shown here. The videos. I had shown video, YY axis is here. Okay, YY axis exactly at the center. YY exactly at the center of the T section. Now you can see this portion, left hand portion of YY is the mirror image of the right hand portion. Exactly. If I fold it exactly here, so this edge will coincide with this. Okay, that means YY axis is the axis of symmetry. So centroid will lie on this axis. So we have to see from bottom where it lies, or from top where this centroid lies. So that we assume that centroid lies from the bottom. It is at a distance of y bar. We have to look at only y bar. X bar is 0 for the given problem because YY axis is the axis of symmetry. Only y bar we have to look it. Okay. So we have divided entire area into two sections. First, so centroidal formula is y bar equal to how many areas you can see? Only two areas. So area of the first and its centroidal axis with reference to the axis. So I have taken x-axis axis passing through the bottom of T, passing through the bottom of T. And y-y axis exactly at the center we have taken. With respect to this x-axis, I am locating y bar. So total area, two areas, A1, Y1, A2, Y2 divided by total area. Okay. So this is the formula to locate the centroid. Y bar equal to A1, Y1. So entire area, like while discussing how to look for the location of the centroid, we have to divide entire area into the finite elemental strips. Here, the finite strips are only two rectangles, A1, Y1 plus A2, Y2 divided by the total area. Okay. So total area equal to A1 plus A2 will be the total area of the composite area. A1 is the area of the topper, first rectangle, that is 150 into 10 plus A2 is the area of the second rectangle. This rectangle is of size 140 into 10. So total area, we got it as 2900 millimeter square. A1 plus A2. This capital A is known to you. A1 is known to you, A2 is known to you. Now we'll have to locate Y1 and Y2 with reference to the assumed x-axis. So with respect to the bottom of T, we'll have to locate the centroid of the top rectangle, centroid of the second rectangle. Now centroid of the first rectangle, because you always know the centroid of the rectangle lies at a distance of b by 2 and d by 2. Now width is 150, depth is 40. So now we don't want the x distance, only y distance we know from the x-axis where this lies. So centroid lies where the two diagonals of the rectangle meets at this point. So this point is located from bottom at a distance of, so it is 140 plus 5 because d by 2, 10 by 2. So from total 150, if I deduct just 5, I'll get 145. Centroid of the top rectangle, y1 is the distance from x-axis. So this centroid of the top rectangle, that is y1, is 145 millimeter. y1 is 150 minus 10 by 2, d by 2. Minus 10 by 2, 150 minus 10 by 2, 145. Now you know the A2, second rectangle. A2 is the area, 140 into 10, and centroid of this rectangle, center, where the two diagonals of this rectangle meet. This distance is 140 by 2, that is 70. Y2 is 140 by 2, 70 millimeter. Now you substitute here everything. Y bar equal to A1 y1 plus A2 y2 divided by total area, we get 108.79 millimeter is the centroidal location. So from bottom, so this y bar equal to 108.79 and x bar is 0 because it lies on the y-axis. So y-axis centroid lies here. Okay, from bottom. Or from top, if you want, you can take the x-axis, reference axis from top. So that is 150 minus y bar, you get from top what is the centroidal location. This is the procedure to locate the centroid of the given composite area. Okay. Now this area is in the form of T shape. So it consists of only two rectangles. So we have divided into two simple geometrical shapes. So the problem is complete here. Okay. So like this, the second problem is in the form of I shape. Okay, we'll have to locate the centroid of this I-shaped section. Now you observe whether symmetry is existing or not. So see here, top rectangle. So this we call it the top flange. This we call it as bottom flange, F-L-A-N-G-E, flange. And this is the web portion, central web portion. So there are three rectangles, 1, 2, 3 rectangles we can see in the given problem. Top rectangle 200 by 10 and bottom rectangle is also 200 by 10 and this is also 200 by 10. So all the rectangles are of same size. So now if I pass exactly at the center from here or here. So both upper portion is the mirror image of the lower portion, left hand portion is mirror image of this. So we need not find out the centroid. Directly it lies where the two axes are meeting. Exactly at the center, I have taken x-axis, exactly at the center I have taken y-axis. Where those two axes are meeting, that will be the centroid. That means top divided by 2, total depth divided by 2. So it is x bar equal to 100 mm. From here, 200 divided by 2, 100 mm. Y bar equal to 200 plus 10 plus 10. 220 is the total depth. 220 divided by 2, that is 110. Sorry, this is 220 divided by 2, 110. 110 mm. 110 mm. It should be 200 plus 20 divided by 2. So it is 110. 100 and 110, this will be the centroid. We need not find out because there is symmetry exists in the given problem. So like this we can find out the centroid. If at all there is a symmetry exists, then exactly at the center where the two axes are meeting, there the centroid lies. If there is no symmetry, then we'll have to look at. Now this is equal symmetric I section. If it is unequal I section, see here. This is another problem where unsymmetrical I section. Now here with respect to y axis there is a symmetry exists, but with respect to x axis instead of taking here, if I take exactly at the center, now upper portion is not the mirror image of the lower portion. So there is no symmetry exists with respect to x axis, but y axis if you observe, if I take exactly here, this left hand portion will be the mirror image. So x bar I can write it as 0 because I have taken y axis exactly here. So centroid will lie on this axis. With respect to the bottommost, every time I am considering x axis is with respect to the bottom. That means I am placing the entire figure in the first quadrant. Okay, like that we can assume upper. So the positive x axis, if I take bottom, so everything will remain positive. Now, how many areas you can see in the given problem? We have to divide the entire composite into simple geometrical shapes. Here I can see 3 rectangles. Top rectangle, middle rectangle, and the bottom rectangle. I have divided into 3 simple geometrical shapes, like 3 rectangles. So area of first rectangle plus area of second rectangle plus area of third rectangle. A1 plus A2 plus A3 will give you the total area. A1 plus. So formula is y bar equal to, there are 3 shapes, A1 y1 plus A2 y2 plus A3 y3 divided by A1 plus A2 y plus A3 will give you the total area. A1, top rectangle area. It is 80 by 12. 80 is the width, depth is 12. 80 into 12. B into D is the area of the rectangle. Now, it's centroid. With reference to the given x-axis, where the centroid of top rectangle lies, from here to the bottom. So, that is 150 minus 12 by 2. That is 6. 150 minus 6, 144 millimeter. Then, centroid of the second rectangle, it lies here. So that is 128 by 2 plus 10. 128, area is 128 into 12. That is this rectangle, 128 into 12 is the A2. Y2 will be half of, it will lie here. I need with respect to x axis where the centroid, that is 128 by 2 plus 10. 128 by 2 plus 10 will be 74 millimeters. Next, A3, area of the third rectangle, 120 into 10. And centroid of this rectangle with reference to x-axis, that is 10 by 2 or 5 millimeter. Like this, you write everything, then substitute in the given form. A1 y1 plus A2 y2 plus A3 y3 divided by A1 plus A2 plus A3 will be 3696. Total y bar, we get it as 69.78 millimeter. Like this, so we can solve the problems. There is another way, all these things, instead of writing this, we can write everything in a table form also. So table form also I'll explain in the next problem after completing this. Now you can see next problem. Here in this given problem, okay, it is asked to determine the centroid of the shaded area. Now this circle is not shaded. So there is a void area. So you can assume one rectangle plate and in that one hole, circular hole is made. Okay. Assume that one rectangular plate, in that one there is one circular hole of 100 mm diameter. This rectangle is of size 400 by 200. So here it is asked you to determine the centroid of the shaded area. Only this centroid I have to locate. So the area, total positive area will be excluding this void area. Only this shaded area will have to calculate. That means area of the rectangle, from the area of the rectangle, if I deduct this circular area, I will get the area of the shaded part. Okay. Similarly to x bar. Now if you pass exactly at the center, so x bar will become 0 because that will be the symmetric axis. Y axis will be the symmetric axis. So now with respect, if I place exactly here at the center, upper portion is not the mirror image of the lower portion. So x axis is not the symmetric axis. So what I am doing, I am assuming x axis passing through the bottom. With reference to this axis, I am locating y bar. So y bar will be, for this kind of, only the shaded area if they ask, so y bar will be total, how many geometrical shapes you can see? Only 2, one rectangle and one circle. From the rectangular area or the centroid of the rectangle, you deduct this circle. We have to deduct it because this is void area. So y bar will become A1 y1. From A1 y1, you deduct this A2 y2. divided by A1 minus A2, because this only the shaded area it is asked. So A1 minus A2, you will get the total shaded area. A1. A1 is the area of the rectangle. 400 into 200 is A1. Y1. Y1 is centroid of this with respect to X. So it is 400 by 2, 200 millimeter. Y1. A2 is area of the circle. You should remember the formulas for the areas also. A2 is area of the circle pi r square. Pi into r is the radius of the circle. Pi into 50 square, or pi d squared by 4 also you can do. Pi r square or pi d squared by 4. So it is area of the circle minus y2. Y2 is the centroid of the circle, always lies at the center. From the center up to the x-axis. That is 400 minus this 100. I will get this distance. From 400, if I deduct this 400, I will get the distance from the centroidal location of the circle up to x-axis. Then substitute everything in this formula, that is A1 y1 minus A2 y2 divided by A1 minus A2. You can get the y bar of this shaded area is 189.114 mm. Like this. So this is without writing in a table form. So directly by applying the formula, we can get the centroid of the given figure. Now the next problem I will explain how you can enter in the table form all these data. Okay. Yeah. This is the problem I have selected, and also it depends upon which quadrant the particular area lies. So if it is in first quadrant, both x bar and y bar of that area will be positive. If it lies in second quadrant, accordingly the sign convention will change. And the area also. If it is shown as void area, if it is not shaded, then it becomes, area becomes negative. Okay, that you should remember while working out problems. Now this is one type of problem. So it is asked you to locate the centroid of the shaded area. Here also this circular area is void area. It is not shaded. This entire composite area you can observe now, where the axis is shown. So it is not asked, it is given y-axis is passing through the extreme left corner. So this is y-axis, but x-axis is shown somewhere in between. See, this is our reference axis. Now our intention is to locate the centroid of this composite area with reference to these two axes. So first we'll see whether is there any symmetry. If I pass exactly at the center, if this y-axis, if I take it here, left hand portion is not the mirror image. And also exactly at the center, that is also. So both x bar and y bar will have to locate for this problem. There is no symmetry exists. Okay. So how many geometrical shapes? Next step, how many geometrical shapes you can see in the entire given geometric composite area. So we can see there is one rectangle, there is one triangular shape, one semicircle you can see, and another circle. Circle is the void area. All other area is shaded one. Only the circular area is void area. So I have divided entire area into, you can see one rectangle. Okay. Then second one. First I had written on the rectangle. Then on second is the triangle. Okay, then third I have considered, this is third one is semicircle, then fourth one is circle. So the total area, composite area of the shaded part will be equal to A1, area of the first figure, plus area of the second figure, plus area of the third figure. So I will get this entire area. From that, I have to deduct A4. A1 plus A2 plus A3 minus A4 will get the total area. Okay. That here, this problem I have solved in the tabular form. Table contains, first one is the serial number. Serial number means how many shapes you have divided the entire area. I have divided into 1, 2, 3, 4. 4 shapes. So serial number 1, 2, 3, 4 I have put. Okay. Then shape. So while writing the shape, first shape is rectangle, second shape is triangle, third shape is semicircle, fourth one is circle. You don't write it. With reference to X and Y, you locate the given, the first shape, rectangle. So with respect to this rectangle, Y-axis is passing through the boundary of the rectangle, extreme left corner. X-axis is also passing through the base. That means for the rectangle shown, X and Y axis are like this. That means rectangle is in first quadrant. See, I had shown here rectangle. X and Y axis with reference to the rectangle, X and Y. Here, these two. And the size of the rectangle is 80 mm and the width of the rectangle is 120. 80 and 120. I had shown here 80 and 120. X-axis here, Y-axis is here. Now you know where the centroid of the rectangle with reference to X and Y-axis. First one, next column is area. After showing the figure, next column is area. Unit for area in millimeter square. X bar, all these dimensions are in millimeter. Okay. X bar in millimeter. Third column is, fourth column is X bar. Fifth one, Y bar. Y bar and X bar are the respective figures. Okay. X bar, Y bar. Then area and X bar. A into X bar. Multiply with the area and X bar. A X bar. So area in millimeter square, this in millimeter. So I get dimensions millimeter cube. Then area multiplied by Y bar. A Y bar in millimeter cube. So many columns. 1, 2, 3, 4, 5, 6, 7 columns are required. Okay, 7 columns. Area of the first rectangle 80 into 120. So 9.6 into 10 cube millimeter square. 80 into 120. Then X bar of this rectangle with respect to X and Y. X bar and Y bar with reference to the axis, selected axis. So X bar with respect to Y axis where the centroid of the rectangle. That is B by 2 and D by 2. 60 and 40. 120 by 2, that is 60. And with respect to X axis, centroid of the rectangle is 80 by 2, 40. Then multiply A into X bar. 9.6 into 60, this is. 9.6 into 10 cube into 40, this is. Okay. First figure is over. Rectangle is over. Now select the second figure, triangle. I have selected the triangle. Now show the X and Y axis. My Y axis is passing through the extreme height of the triangle like this. And the X axis passing through the, like here the X axis is passes. The X axis I show here. Y axis here. Now with reference to Y axis, centroid lies. So it is positive X bar. From here, because wherever there is 90 degree, from there it is 1/3 of the base. Base is this. 1/3. 1/3 of 120. So 120 by 3, 40. X bar is 40. But Y bar with reference to this X axis, Y bar is below the reference axis now. Okay, centroid of the triangle is here. So Y bar of the triangle is below the reference axis. So I have written minus. Since this figure is in fourth quadrant. Now my X axis is here, Y axis here. So the figure, respective figure is in fourth quadrant. So Y bar is negative. That's why it is 60 by 3 minus. So minus 20. I have written it as minus 20. Y bar of the triangle is minus 20. Then multiply area into X bar, area into Y bar. 60 into 120, we get 3.6 into 10 cube into 40. So it is 144. This into Y bar minus. So minus 72 into 10 cube. Okay. Then consider third figure. Third figure is semicircle. So X axis is here, Y axis here. Both are in the, this figure lies in the first quadrant, no doubt. And see X axis with respect to the semicircle where it lies. So it is 80 mm below the base of the semicircle. See here, semicircle it is shown. Y-axis here, x-axis here. So semicircle, base of the semicircle is 80 mm below this. So this is entire semicircle. Centroid of the semicircle we have already derived. Centroid of the semicircle lies at a distance of 4r by 3 pi from the diametral axis. From the base of the semicircle, it lies at 4r by 3 pi. X bar, since here centroid lies at the center. Okay, that is r, radial distance. Here this is r. X bar is radius of the semicircle. Y bar is 4r by 3 pi. So 4r by 3 pi from the base of the semicircle. But I need with respect to x-axis. So this centroid of the semicircle lies from the x-axis 4r by 3 pi plus 80. Okay, 4r by 3 pi plus 80. So like this, so both are positive, so it is positive. Then lastly, the circle. Centroid of the circle lies at the center. So center of the circle with respect to y-axis, where it lies with respect to x-axis. So center of the circle lies at 80 mm, y bar is 80, x bar is radial distance, that is 60. Since it is 60 and 80. Area, since it is not shaded, so area is negative, minus pi r square. Minus sign is put in the area, so minus, since it is void, it is not shaded. Then while doing the summation of area, A1 plus A2 plus A3 minus A4, I will get summation of A. Finally, after doing this, while multiplying A into x1, this becomes negative, since area is negative. This into 80, you get negative. These two columns are negative, as well as this column is negative, because y bar is negative here. So be careful about the negative sign value. Then summation of A. Summation of this column, third column, summation of AX bar, summation of AY bar, you have to do. Summation of A, summation of AX bar, summation of AY bar. Okay, by considering the negative sign also. So you get 13 on this, AX bar is so much. Then X bar equal to summation of AX bar divided by summation of A. I get 54.8. Summation of AY bar, Y bar equal to summation of AY bar divided by summation of A, I get 36.9 mm. Like this. So you can write everything in the table form and you can analyze it neatly. So that though no confusion will be there. Okay? Understood? Am I going very fast? Student? Hello? Understood the concept?
Yes, ma'am.
Okay.
Yes, ma'am.
See, all these problems again you work out. Already I had uploaded in the WhatsApp. Okay. So one more problem, similar type of problem I had solved here. Directly I had given you the answers. You can go through this problem. Just analyze this problem also. Okay. So there is, you can see one rectangle, one triangle, and these two void area. Out of this total shaded area, you can deduct this semicircle and there is one rectangle. These two are not shaded. So the total area will be A1 rectangular area plus triangular area minus semicircular area minus rectangular area. Like that, 1, 2, 3, 4. So we can divide into 4 shades. I have to locate centroid of this, and there is no doubt x and y axis entire figure is placed in the first quadrant itself. So minus and plus will not come with respect to x bar and y bar. Only area of this rectangle is minus, area of semicircle is minus. So either you can write in the table form or you can do it directly. You write everything in the table form and see. I had written directly. So total area equal to A1 plus A2 minus A3 minus A4. I will get so total area. Next, X1 and Y1 I have written because X1 and Y1 of all the figures will be positive, entire area is in. So with respect to Y-axis, X bar you will get, with respect to X-axis, each and every figure. See what is X1 and Y1. I have written here X1, Y1, X2, Y2, X3, Y3, X4, Y4. All the values I had given here. You check it again. Okay. And apply in the further. X bar equal to A1, X1, A2, X2. These two are positive. A3 and A4 are negative area. So minus A3, X3 minus A4, X4 divided by A. If you write in this formula in this way. Y bar equal to A1, Y1 plus A2, Y2 minus A3, Y3. Minus comes because area is negative. So once area is negative, minus A3, Y3 minus A4, Y4. And for the total area also, A3 is negative, A4 is negative. A1 plus A2 minus A3 minus A4. So this. So you can solve this way also, without the table form also. So this problem I have solved. I have not entered in the table form. Directly I solved and I have given you the answer. You solve this problem in the table form. Okay. So table form, initially shape, draw the shape, then write the area. Then X1, Y1, check whether you are getting same values. Okay. Then area into X1, AX bar, area into X2, Y2, Y1, AY bar. Then do the summation. A1 plus A2 minus A3 minus A4. So you will get summation of A, summation of AX bar, summation of AY bar. Finally, X bar equal to summation of AX bar by summation of A. Y bar equal to summation of AY bar by summation of A. You will get this. Okay. Work out this problem in the table form. So everything it is shown, all the dimensions are shown here. Based on that, area of the rectangle B into D, area of the triangle half base into height, area of the semicircle pi r squared divided by 2, area of this rectangle is B into D. Okay. This area. Got it? Hello?
Yes, ma'am.
Yeah, understood.
Yes, ma'am.
These problems, you work out,
Yes,
go
ma'am.
through all these problems again, okay? This is regarding the centroid. Centroid concept is entirely different from the force analysis, resolution, or the support reaction, whatever we have seen earlier, okay? This centroid and moment of inertia, fourth module is entirely different. Here, the force concept will not come into picture. Entirely different concept. Only the thing is you have to draw the diagram neatly and analyze it. But you should remember the area of each and every figure and the centroidal location of each and every figure, where it lies with reference to the axis. Centroidal location of that area with reference to the axis. Okay. Drawing neat figures are very important. Work out these problems again. I'll upload some more problems for your practice. You can go through those problems. These problems are not taken from the book. I have taken from the Beer and Johnston textbook.